So problem 263, number 108, is a linear and angular speed problem. This one is about a saw blade has a diameter of 7 1/4 inches and rotates at 4,800 RPM and wants to know the angular speed of the blade in radians per second. Okay, so we have 4,800 revolutions. That's revolutions. So a revolution is how many radians? 2 pi. So we have 4,800 times 2 pi radians per minute, except what we were asked to do was get radians per second. So we're going to divide by 60 seconds per minute. So there are minutes cancel, and now we've got 4,800 times 2 pi radians per 60 seconds. If we divide 4,800 by 60, that leaves us with, what, 60? No, 80. How about that? 80 times 2 pi radians per second is 160 pi radians per second. Okay, so that's the angular speed. It's 160 pi. Book is not real consistent. Sometimes it'll turn that into a number. Sometimes it'll leave it as a multiple of pi. This time it left it as a multiple of pi. We may want it that way later. So the A part, 160 pi radians per second. Then the B part of the problem wants to know linear speed. Okay.
So to find linear speed, we first start with the arc length, S equals r theta. We divide both sides by time, so S over t is the linear speed, r is the radius, theta over t is the angular speed, which we just found in part A of the problem as 160 pi radians per second. The radius was given to us, actually the diameter, as 7 1/4 inches, so we divide that by 2 to get a radius, divide by 12 to get feet, and then multiply by the angular speed of 180 pi radians per second. That gives us the result of 151.8 feet per second as the linear speed of the saw blade.
Okay, and then the next one was 264, number 110. This is a computerized spin balance machine that rotates a 25-inch diameter tire. So we draw the same circle. This time it has 25 inches for the diameter, and it rotates at 480 RPM. Okay, 480 RPM. And it wants to know, find the road speed in miles per hour at which the tire is being balanced. Okay, so road speed is the same as linear speed. That's the how fast the car would be going. So that's a linear speed. So again, linear speed is our angular speed. But we need to convert RPM into radians. Okay, so we multiply this by 2 pi. And we get, what, 960 pi radians per minute. And our radius is 25 inches over 2. This is 960 radians per minute. But what we want is miles per hour. Okay, so we've got to go from inches to miles. Well, that's a lot of fun, right? So inches, 25 over 2 inches. We've got to divide by what? 5,280 feet in a mile, and 12, there's a pi there, right? Am I going the right direction, or should I be multiplying? Okay? We're dividing by 5,280 feet in a mile, 12 inches in a foot, but that is per minute, and we want hours, so we've got to multiply by 60. So all of that junk is just getting the conversions right, and then we have 960 pi radians per minute. Okay, so this is the radius. This is converting inches of radius to miles, right? So we're dividing by feet in a mile and inches per foot. We're converting minutes to seconds by multiplying by 60. And so here we go with poking buttons again. 25 divided by 2 times 60 divided by 5,280 divided by 12 times 960 times pi, and we get 35.7 as an answer, and that's in miles per hour. Miles per hour. Okay? How about that? Did everybody follow all of the hand waving that went with that one? Yes, Mr. Wyatt. No, Mr. Wyatt, I have no idea. Okay, so that's 35.7 miles per hour on the road speed. And then it's asking us to do something backwards. At what rate should the spin balance machine be set so that the tire is being tested for 70 miles per hour? So you got a couple of choices there. You can plug in 70 and work this back to what does that have to be. Or you can cheat and say that 35.69 is pretty much half of 70. So if you double the linear speed, you've got to double the rotational speed or the angular speed. Since we started out at 480, you multiply that by 2 and you get 960 RPM. If you actually go through all of the calculations of plugging in 70 here, 70 there, and working that back to RPM, you get 961. Okay? Or 941, sorry. 941.